Hello everyone, welcome to Fitness Coder. So today we'll be looking at a new problem. It's called rotate image. It's a medium level problem on Leetcode. As you can see, there is a matrix given to us. It could be 2D matrix of any size. So we can see that they have asked us of its 90-degree rotation in output. So 3 by 3 matrix should look like this, like 1 2 3 4 5 6 and 7 8 9. If it is given, then it should be like 7 4 1 8 5 2 9 6 3. Same goes with example 2. It doesn't matter what the size is, approach will be same for every one of them. So previously I used to think like we could go for a cyclic rotation into it, but it was not working well. So I had to come up with a optimum approach which is based on a mathematical principles. As you can see, the matrix is given. What we can do with this matrix, we can get a transpose of it, right? So every time when we see this matrix, we can convert its row into column. So 1 2 3, which is given as row wise, will be converted into column, and same goes with the others rows. So 1 2 3 will be in column, 4 5 6 will be in column, and 7 8 9 will be in column. So once we get those, we just have to think about the edge cases or the endpoints or the end columns. So first column and the end columns, those columns needs to be swapped, and then we will land up on our answer. So for convenience, I have taken this example into a separate window. Here we can see that after transpose, this matrix will look like this: 1 4 7 2 5 8 3 6 9, and the only part will be remaining is like to swap the columns, first column and the last column, first column and the last column. Every time 1 is swapped with 7, 2 is swapped with 8, 3 is swapped with 9, and we'll get our answer after that. So there is one catch in this problem, because the swapping is a pretty much complicated thing. We need to take care of this 4 5 and 6 should not be swapped, or just to make sure about the time complexity, we should avoid that. The problem or the approach that we are thinking of is, if we are looking for a zeroth column, then it should swap with the second one, and next time if there is a larger matrix, our I should go forward and our swapping column should decrease. So if there was a columns, there were four columns, then zeroth column will be swapped with the third one, and then first column will be swapped with the second one. So this is how it goes, and this approach will follow. So for that edge case, we need to make sure that I should always be smaller than this matrix dot length minus 1 minus I, because when we are thinking of I, and it should be swapped with the n minus 1 minus I column, this middle column, it needs to be taken care of, and just to maintain the time complexity. So let's see how it goes with the code, and we'll start with the transpose of it. So let's code. First is transpose of the matrix. So for that we need rows iteration and column iteration as well. So for column we have taken j here equal to 0. Then for matrix, here we are thinking of to follow the proper way of I and j conditions, because whenever we are thinking of converting into a transpose, then 0 0 will be placed at the same place here only. 0 1 will be swapped with the 1 0, and 0 2 will be swapped with 2 0. So every time this I and j and I, so swapping, if it is I and j, then this one will be j and I. So this is how this swapping is going, and we are making sure that I should be smaller than j, so that just to avoid a repetitive swapping, and we need to end up it in transpose 1, so that's why. So if I less than j, then what we need to do, we need to swap them. We need to swap with them each other. So matrix of I j, and this should be swapped, this should get swapped with similar one, matrix of j and I. And here for j and I, we have taken another variable temp. This will be having its value, and now transpose is done. So just to check it out how it looks, we are just printing it just to make sure whether it looks similar to our image that we have drawn in the separate window. So yeah, here I would be taking print statement along with the matrix parameters I and j and a space between them, and also just to make sure in a matrix form I have to give space between them. So println, yeah, if you're just printing it, our answer would be wrong in this case currently, because we're just checking transpose matrix. So let's check here, 14725,369. This output I'm talking about, 14725,369. Just cross checking it, 14725,369. So transpose is done. After that, we need to make sure column swapping. So here I'll be writing a separate code for swapping columns with the similar I and j loops. Here, as I have said, we just have to make sure about the time complexity that this middle column should not get swapped with itself. So I should be lesser than this one, meaning n-1 minus I, so that I should not end up on this column and rest of the columns gets covered. So here, as we can see, 0 0 gets swapped with 0 2, again 1 0 gets swapped with the 1 2, 2 0 gets swapped with the 2 2. So it's like j here, I here, again j, and this part is n-1 minus I. So if you can do the calculation later on as well, so this will move into this formula only every time, and we have to make sure I should not cover the middle column. So going ahead with that, I should be less than, if I is less than matrix dot length -1 minus I. Okay, if I is less than this, then we need a temp variable into which we would be storing this j and then I, and on this j and I we need another value which is matrix of j and matrix dot length -1 minus I. So this is the like n-1 minus I in from the image, and at this place only we need another one. So at this place, matrix of j and this length -1 minus I, we need our temp value. So once we are getting this, I think we are good with the code, and we can run it just to make sure everything is working fine. So columns are swapped and transpose also done. So let's check whether we are getting our answer, expected one. Okay, for 3 by 3 it's working fine. Let's check with this 4 by 4 matrix, another test case. Let's see how it goes, and accepted for that. Okay, let's try submitting it. Okay, 0 millisecond, good. So that was all for this video. Thanks for watching everyone. Stay tuned.